Hello, this is Chuck Winkelmann explaining problem 2 on homework P.1. The problem says, prove the following. Hint, you may assume if x and y are integers and x times y equals 1, then x is either positive or negative 1. The claim states, let a be an integer. If there exists an integer n such that a divides 4n plus 3 and a divides 2n plus 1, then a equals 1 or a equals negative 1. I am going to start by sketching out a no-show table. So our step P is our hypothesis. So a divides 4n plus 3, a divides 2n plus 1, and then a and n are both integers. And this is our hypothesis. And then at the end we want Q, which is a equals 1 or a equals negative 1, and we don't know the reason for that yet. So our step P1 is going to be the definition of divisibility. And we are going to say 4n plus 3 equals a times k for some integer k, and then 2n plus 1 equals a times n for m is an integer as well. And then P2, we are going to solve for n in our second equation, and then we get n equals am minus 1 divided by 2, and that is just algebra. And then we are going to plug that into this equation. So our P3 is going to be 4 times am minus 1 over 2 plus 3 equals ak, and that is just substitution. And then we solve that out and we get 2am plus 1 equals ak, and that is just algebra. And then I want to rearrange so I have my a's on both sides, or on the same side. So we have ak minus 2am equals 1, and that is just rearranging, so algebra. And then I am going to factor out an a, so we have a times k minus 2m equals 1, and that's factoring. And then we have P7 is k minus 2m is an integer, and we know that by properties of closure. And then finally we can get to the end result of a equals 1 or a equals negative 1 by the hint given to us that two integers multiplied together equaling 1 means that one of the integers has to be either positive or negative 1. So then we can see down here we have a formal proof, and it says, we will prove this statement by direct proof. Let a be an integer and suppose there exists an integer n such that a divides 4n plus 3 and a divides 2n plus 1. By the definition of divisibility, this means that there exists integers k and m such that 4n plus 3 equals a times k and 2n plus 1 equals a times m. Rearrange the second equation to solve for n equals am minus 1 over 2. Now, substituting that into 4n plus 3 equals ak, we get 1 equals ak minus 2am, and then we factor the a out and we get 1 equals a times k minus 2m. Since a is an integer and k minus 2m is also an integer, the only integer values of a that satisfy this equation are a equals 1 and a equals negative 1. Therefore, we have proved that if there exists an integer n such that a divides both 4n plus 3 and 2n plus 1, then a must be either 1 or negative 1. And that is the end of the proof. Thanks.